will create curiosity when I tell you what they do. And I'm going to explain it with an oxymoron. They developed a cement-free concrete made entirely from industrial waste, cutting carbon by 80% and saving up to 90% of water. It gains strength in just 3 days, slashes cost, and scales through green cement and precast products. Sustainability just got faster, smarter, and profitable. I'd like to call upon stage Nanjudan and Vijay to see what they have to talk about their product.
Hello and good afternoon, friends. I am Nanjun Rao, the Chief Research Scientist from the Department of Civil Engineering and Science, Bangalore. I am one of the co-founders of Novacrete. I have with me my teammate and the co-founder, Mr. Vijay. Now, as all of us know, water is the largest consumed material on this planet. And we should know the next largest consumed material is concrete, and we may not be surprised about it. The way we are developing our infrastructure in the country, the concrete is going to be consumed in larger quantities. And one of the three components of concrete, the binder is the Portland cement, then the fine and the coarse aggregate, and all of them are mined materials. And the issue of carbon emissions, which we are all dealing with in order to address the issues of global warming and the associated climate change, as construction industry, we have a big responsibility to bring down the carbon dioxide emissions into the atmosphere. The construction industry itself contributes nearly about 11 to 13% from among these things, and 8% comes from the production of Portland cement concrete itself, which works out to about 2.5 billion tons of carbon dioxide annually. This has to be addressed. The second issue with concrete is, with Portland cement as the binder, is the need for curing for the hardening process, which again consumes large amounts of water. Roughly about 250 liters of water is used for the process of curing for the hardening to take place. And the other issue with Portland cement as the binder in concrete is that it needs 28 days curing with water to achieve its targeted strength. Now, can we think of concrete which we can make without any Portland cement, that is zero cement, and also look at concrete which does not need any water for curing, so that we are addressing the two important issues from environmental point of view. And the third thing is, can we think of reducing the number of days for its full strength attainment from less than 28 days, and that is what we are looking at in our technology, that we can achieve this kind of a strength in just 3 days, reducing it from 28 days compared to Portland cement as the binder. And how do we achieve this? What do we do? And we have done this. And how we have done it is the proprietary Novacrete cement, which essentially utilizes the industrial waste and agricultural waste as a precursor material, and that has been associated with a proprietary another material which together will become the binder in production of concrete, completely eliminating Portland cement and thereby reducing the carbon dioxide emissions. Now, the key components in the precursor materials that we recommend to use are the material which is having calcium, alumina, and silica, which is there in the waste materials. Now, the product manufacturing itself, we are recommending is a same process. There is no change in the process, that you have to mix these binder along with the aggregates, and you pour it into the mold for the required shape, and you will end up in such precast products with this new binder, which is zero cement, zero Portland cement concrete. Now, these are the products that we have already developed, the paver blocks of different shapes. Now, just for illustrative purposes, let us look at the conventional concrete where ordinary Portland cement is used, and the constituents to develop an M30 grade concrete, which will have about 16% binder, which is the Portland cement, and the rest of the things is coarse and fine aggregates and water. Now, as against this, the new binder that we are proposing is the Novacrete one, which is also uses the same proportion of binder, but it is not Portland cement. So, we are not looking into any changes in the constituents of making this new concrete, which is a Nova concrete. Now, what is it that we have achieved in terms of the performance? Because we changed binder, which is low carbon, that is enhanced performance in strength we are able to enhance this strength by about 2 times. And coming to the durability aspect, which is a measure is water absorption, we are able to reduce the water absorption from the conventional concrete, which is 1.54%, to as low as 0.15%, which itself is an indicator of the performance of this new binder concrete, which is Novacrete. Now, the applications that we are looking at is the paver blocks and the masonry units, which are lightweight, aerated concrete blocks, and also facade materials. Now, this Novacrete concrete, it has a very good advantage that there is no change in the operations from what conventionally we are using or we are doing, and also there is no change in the machinery to adopt this new technology. Now, the magic keys, as I already told, is a summary: zero cement, zero Portland cement, then there is zero water for curing, and finally, we are able to achieve the targeted strength in 3 days from as compared to 28 days in conventional Portland cement binder. Now, this magic has seen that there is a reduction of 80% carbon emissions, and there is ensuring circular economy because we are using waste materials as a precursor here. Now, one more thing that is an advantage here is that we are able to get about 10 to 15% cost saving by adopting this new binder, which we call as a proprietary Novacrete binder. Now, what are our offerings? The offerings is finished products like pavers. We can look at all other kinds of precast products for construction industry. We are also offering what is called a Novacrete cement itself, similar to Portland cement, bagged it, and you can supply it to people. And the last one is our consulting services, expert advice. Now, traction is this Novacrete has been incubated in FSID at IISC Bangalore, and the product has been launched in Bangalore Tech Summit on 19th edition. Then it has also been featured in Economic Times, and we also received grant from both DST and Durada funding. Now, these are some few pictures of our traction. Now, what we are looking at is, we are also looking at pilot work orders from the Bangalore Mahanagara Palike, and a few private developers also. Now, our team, myself, Dr. Nanjun Rao, who is the Chief Research Scientist at Department of Engineering at IISC Bangalore. We have Vijay with us here and Mr. Nitin as a team. And the entire cutting-edge technology that we have done has already been validated at Institute of Science through FSID and also at NITK Surat.
10 seconds. Do you want to finish something?
This is what we have, the partnership opportunities that we are looking for: paid pilots, manufacturing collaborations, and partnership with construction firms and enterprises. Thank you.
Thank you so much. On to you, jury, for the questions.
Can you share some more details in terms of how much construction has been done currently using Novacrete?
Sir, hello, am I audible? So right now we have received around 3 lakh square feet for the pavers placement. So that's the first work order what we have received.
Can you share some more details in terms of the cost aspect, I mean, what I have understood from is you have a technology and a product. You are trying to find partners, distributors, probably precast manufacturers. Is that correct assumption?
Correct.
Yes.
So we have a network of manufacturers from Karnataka in and around. So where they are procuring our binder, like we want to partner with them because we are mainly in the binder business.
Okay. And the raw material is the same which we had seen in one of the other ecopaths. It's the same slag,
No,
geopolymers. What
different.
kind of material are you using?
Yeah, sir. The precursor that we are looking for as a material can be an industrial waste. It can also be an agricultural waste. Essentially, the material which we are saying should be used as a precursor in developing this new binder should have certain chemical constituents which are like alumina, silica, and calcium oxide. And any material which is available with these chemical constituents will be good enough to serve as the purpose of precursor for this new technology.
So do you have a tied up sources of that, or like how does it? Because from what you are saying, it seems like you don't have fixed tie-ups for that. I mean, please
Sir,
explain where is your ingredients going to come from?
Correct. We have a tie-up with few of the vendors for two of our sources, like for the industrial waste.
Can you be a little bit louder?
Your voice is...
Am I audible? Yeah. So we have a sources for of our vendors for the waste sources.
We can source these materials from industry, thermal power plants. We can source it from the steel industry. We can also source it from agricultural waste, which I will say rice as ash, bagasse ash, and other things. Now, one of the things that pollution is happening in New Delhi is burning of that. In fact, a controlled burning, we can address the issue of pollution there, and that could be a valuable product as a precursor in this technology. Any of the agricultural waste can be controlled burning, and you can get a material which has calcium oxide, silica, and aluminates, and that's good enough.
Thank you. Any questions from... I think some conversations need small discussions and some longer. I think off the stage you'll have some more questions, but I'd like to take some questions from the audiences. I hope you all are selecting your favorite construction tech pitch, right? From this you are going to select one. So can I have a hand raise if for anybody who has a question for them? Yes, the gentleman over here.
Hi, sir. It's a nice technology which it looks. You said this is commercially it's 15% lesser expensive than the concrete. How is that? Means without production, without factories in place, how you establish that 15% less cost?
So see, the normal cement bag will cost around 400 rupees. So our green cement binder is less than the cement bags what we're selling it to the manufacturers. So that's where they'll have that cost advantage of producing the finished products.
I think, were you able to hear? Is there?
I could not.
Were you
Yes,
able to get it?
can we have a mic, please,
Shall I
if
pitch in?
possible?
Yeah.
Yeah, let me tell you, we know the cost of a 50 kg bag of Portland cement, right? And we know how much proportion has to be added to produce our new proprietary binder, which is a precursor, which is already available in the market. We know how much has to be proportioned. As I mentioned to you, it is 16%. We are not changing anything. And we know how much it goes. And from the cost comparisons which is available today, commercially available, we can easily make an estimate that it is going to be 10 to 15% less.
Is this including the curing period of also?
In fact, if you want to account for that, you will get a much bigger margin, in fact, because your product cycle, the production cycle will get reduced. Instead of waiting for 28 days, you will now wait only for 3 days and you can produce more number of products. And if you can add that, it will be further savings. It is not accounted now. Because if you want to look into that, somebody should also be buying at that rate, right? So therefore, we have not included that.
Thank you.
Thank you.
Thank you. I think that was the questions that we had from the audiences as well. A round of applause, guys.